Okay. Couple little minor topics here. If I go back to this... Oh, of course it restarted. If the sidereal day is one rotation, and the apparent solar day is noon to noon, or the time it takes the sun to hit the meridian twice, are these the same amount of time? When the sun goes from the same place back around to the same place, is that one rotation of the Earth? Are these the same amount of time? Excuse me. It really seems like they are, okay? It seems like they are, but it turns out they aren't, for one important reason. In fact, if they were the same exact amount of time, we probably wouldn't have bothered giving two different definitions and two different names. So why are they different? Okay, let me set you up. All right, here we go. Let's say that the sun is here. Okay. The sun is there. And let's say that the Earth is down here. Let me zoom in on that a little bit. There we go. And let's say that there's a person right here. Now, this person would have the sun on their meridian because they're right underneath the sun. So that means it's noon for that person, okay? And it seems like if the Earth spun one time, he'd end up back right here, and it would be noon again. But we're ignoring one thing that the Earth is doing every day, okay? The Earth does spin once every day, but what else is the Earth doing? What else is the Earth doing during that day, other than spinning in place? What else does the Earth do? Well, it is tilted, but I'm talking about another motion. Does the Earth stay right here all day? No, you're right. It also orbits the sun. So as the Earth rotates, it also moves over. And I'm exaggerating this a little bit to make this easier to see, but check it out. Here we go. While the Earth is rotating, the Earth is moving over. So when one rotation is done, that guy is going to be standing right there. When he spins around the Earth once, he'll be standing right there. Now here's my last question of the day. There we go. Last question of the day, I think. Is it noon for this person? Is it noon for this guy right here when he's standing right here? Yes or no? No. Because the sun isn't perfectly over his head anymore. Because the Earth moved over while the Earth was spinning, when one rotation is over, he's no longer pointed at the Earth. So what's the Earth going to have to do to get the sun over his head again? It's going to have to spin a little bit more. So the Earth would have to spin a little bit more than one rotation to get this man back to noon. So I lied. I have a couple more questions. Here we go. Based on this, if noon to noon is to get this guy from here to here, and one rotation is from here to here, which type of day is longer? The sidereal day that's one rotation, or the apparent solar day that is noon to noon? Which one is a little bit longer? Is the apparent solar day with noon to noon a little bit longer? Or is the sidereal day with one rotation a little bit longer? So I think you guys got a little flipped here. It's okay. That's okay. Check it out. Remember, one rotation of the Earth is over when he gets to right there. See how he's pointing in the same direction here and here? So one rotation is over right here, and we said that the Earth would have to spin more than a complete rotation to get him under the sun again. So that means to get him back to noon, the Earth had to spin a little bit more than a complete rotation. And so that means that the apparent solar day is actually a little bit more than one rotation of the Earth. So the apparent solar day is just a couple of minutes long. It's on the order of like around a minute or so longer than a sidereal day. It's been a long time since I looked up the exact amount of time, but it's around that. So here's the real final question. Which one is our clock based on? Is our clock, like the clocks that we use like on our wristwatches and on our phones, are those based on an apparent solar day or a sidereal day? Are they based on the apparent solar day, which is based on the position of the sun? Or is it based on a sidereal day that's the rotation of the Earth? Excuse me. This is what everyone thinks, and that it's totally okay that you guys actually got these last couple a little bit wrong, because we're always told to think of a day as one rotation of the Earth. A day is one rotation of the Earth. And a sidereal day is one rotation of the Earth. But our clocks are actually based on an apparent solar day. Because check this out. We want it to always be noon when the sun is over our head. So we have to lock our clocks into the sun, okay? If we were basing our days, our clocks on a sidereal day, then this right here, this would be noon. So that would be 12, right? And then this would be 12. And the sun wouldn't be above our head. And if we waited another day, the Earth would have moved even further. And then this would be 12. And you could see here, then the sun would be off to your side on that day. So, and if we waited long enough, eventually, I'm sorry, I'm just going to draw on top of my picture here. But if we waited till the Earth was over here, that would mean that noon would be in the middle of the night because it's facing away from the Earth. So in order to keep the sun in the same place every day, we base our clocks on the actual sun, not the actual rotation of the Earth. So one 24-hour day is actually like a little bit more than an actual rotation of the planet.